Dear friends, this is my second lecture on electrodynamics, and we will discuss first the electrostatic field. I am Dr. K.C. Jain. So electrostatics means the charge is stationary. If as we know that if comb and hair or glass or silk, if we rub, then a charge is developed, and the positively and negatively charged are developed, and we know that there are in an atom the positive and negative charge are equally there present there. So unlike charges attracts and like charges, as already we know, they repels. If we have two charges and if I want to calculate the force between them, then we can use the Coulomb's law, and Coulomb's law says that the force is directly proportional to the charge, and it is inversely proportional to the square of the distance between the charges. So F is proportional to Q1 Q2 upon R square, and F is equal to K Q1 Q2 upon R square if you remove the sign of proportionality, and K is 4 pi 1 upon 4 pi epsilon naught. Epsilon naught is known as permittivity, and it is equal to 8.85 into 10 to the power minus 12 Faraday per meter. Now, the space of any charge in which it influences can be experienced by other charges is called electric field, and it can be represented by imaginary lines called electric field lines. So if it is positive charge, then the line will start from the charge, and if it is negative, then we can say the lines ends at the charge, and in positive charge lines begins. The tangent drawn on these lines shows the direction of electric field, and two lines never intersect, and closeness of lines shows the intensity of the electric field. This type of situation or this type of diagram we know when we plot for the magnetic lines in case of in a magnet. Now the electric flux is number of lines that passes through a given surface. D phi we can write as E dot ds, and phi is equal to surface integral E dot ds, that is equal to E ds cos theta we can write, and theta is angle between direction of E and line perpendicular to the surface. So electric field is measured as electric field intensity. So we can write E is equal to limit q tends to 0 F upon q, and F is we can write q upon 4 pi epsilon naught R square, and that is R unit vector. If q is considered at the center of the sphere of R radius, then epsilon naught E is equal to q upon 4 pi R square, and that is charge upon area of the spherical sphere, that is surface charge density we can write, and epsilon E is equals to D, and that is equal to rho s, that is surface charge density. So electric flux density, that is equal to charge density. So D we can write equals to epsilon naught E. In medium, D is epsilon E or epsilon naught epsilon R E, and epsilon R, that is relative permittivity, we can write E epsilon upon epsilon naught. D is electric flux density, and the unit is coulombs upon meter square. Divergence and curl of electric. Now we will write the divergence and curl of electric field. So divergence and curl of E are two fundamental postulates of electrostatics. So Gauss's law states that the total electric flux through a closed surface E dot ds is equal to q enclosed divided by epsilon naught, or D dot ds is equal to q enclosed, as in the just above we have derived D is equal to epsilon naught E. So we can in place of E we can write D upon epsilon naught, and epsilon naught is cancelled, so D dot ds is q enclosed. We can write like this. Now the q enclosed is equal to, as we know that the rho dV, because dV is the volume element. So E dot ds we can write directly 1 upon epsilon naught rho dV. So by divergence theorem we can write E dot ds is equal to del dot E dV. So del dot E dV is equal to 1 upon epsilon naught rho dV, or if we compare, then del dot E is equal to rho upon epsilon naught, or del dot D is equal to rho. Then known as divergence of electric field, also known as the differential form of Gauss's law. So this del dot D is equal to rho, or del dot E is rho upon epsilon naught, is known as the differential form of Gauss's law. Now the curl of electric field. Let a point charge Q moves from A to B in an electric field E. The force on Q is F equal to QE. Therefore, the work done dW will be equal to minus F dot dl, and in place of F we can write QE, so it is minus QE dl. Work is done by external agent, so negative sign is there. Now the total work done W, that is equal to minus Q E dot dl. We can integrate it, so W upon Q is equal to minus E dot dl, and that is equal to VAB, that is potential difference. The potential, and E is Q upon 4 pi epsilon naught R square. So VAB is equals to minus integral RA to RB and Q upon 4 pi epsilon naught R square dr. So we can integrate it. So we will get by this mathematical expression VB minus VA. If RA tends to infinity, then VA equal to 0, and VAB is equal to VB, and that we can write Q upon 4 pi epsilon naught RB. In general, V is equal to Q upon 4 pi epsilon naught R. So V is equal to W by Q. W here is work done and Q is the charge, and that we can write equal to minus R integral from infinity to R E dot dl. So VAB is equal to minus VBA, or VAB plus VBA is equal to closed surface E dot dl, that is equal to 0. So E dot dl is 0. So from Stokes theorem, E dot dl we can write del cross E ds, that is equal to 0, and del cross E is equal to 0. That is curl of electrostatic field is always 0. The one more important point here is to discuss the Laplace and Poisson's equation for electrostatic potential. So the electrostatic potential V is already we know from the previous discussion, V equal to minus E dot dl, or dV is equal to minus E dot dl. So according to the theorem on partial derivatives, del V upon del x dx plus del V upon del y dy plus del V upon del x dx is equal to minus Ex dx plus Ey dy plus Ez dz. So if we compare, then Ex is equal to minus dV upon dx, Ey is minus dV upon dy, and Ez is minus dV upon dz. Since E is equal to Exi plus Eyj, we can write Ezk. So E is equal to electric field, we can write minus dV upon dxi plus dV upon dyj plus dV upon dzk, or E is equal to minus del V, that is gradient V or grade V. This negative sign shows that direction of E opposes to the direction in which V increases, and from Gauss's law we can write del dot E is equal to rho upon epsilon naught. So if we use these two, then del dot minus del V is equal to rho upon epsilon naught, or del square V is equal to minus rho upon epsilon naught, that is known as Poisson's equation. And this is derived for homogeneous medium. A special case when charge free region, then rho equal to 0, and in case del square V will be equal to 0, and that is known as Laplace equation. You can see the notes of this derivation.